When we say that exercise lowers blood glucose, it's easy to picture simply burning sugar. But that explanation, it misses what's really happening and why exercise works even when insulin doesn't seem to. Let's walk through this step by step, and we'll start at the cellular level. First, glucose doesn't have the ability to move on its own. Glucose can't just drift from the bloodstream into the muscle cells. It needs a doorway. That doorway is a transporter called glucose transporter type 4 or GLUT4. Under resting conditions, GLUT4 mostly stays inside muscle cells. Insulin's job is to signal GLUT4 to move to the cell's surface and let glucose in. In insulin resistance, that signal is too weak. Insulin is present, but the door doesn't open well. This is where exercise changes that story. When muscles contract, they activate internal energy sensing pathways, especially one called AMP, activated protein kinase, or AMPK. AMPK does something important. It tells GLUT4 to move to the cell surface without needing insulin. That means that glucose starts entering muscle cells immediately. Blood glucose levels drop during and shortly after activity. This works even in people with significant insulin resistance. This is why exercise can lower glucose the same day, sometimes within hours. This insulin-independent pathways is one of the most powerful and most underappreciated effects of physical activity. And the story doesn't end when the workout stops. After exercise, muscle cells actually become more sensitive to insulin for the next 24 to 72 hours. That means the same amount of insulin can move more glucose. Less insulin is required to control blood sugar, and post-meal glucose spikes are much smaller. This improved sensitivity happens because GLUT4 expression increases, insulin signaling pathways become more responsive, and fat accumulation inside muscle cells decreases. This explains a key clinical reality. If exercise is stopped for even several days, insulin sensitivity declines again. The benefit is real, but it's use dependent. Exercise also affects the liver. Blood glucose isn't controlled by muscle alone. The liver also plays a major role, especially in fasting glucose. In insulin resistance and type 2 diabetes, the liver often releases glucose when it shouldn't, particularly overnight and between meals. With regular exercise, it improves hepatic insulin sensitivity, it reduces inappropriate glucose production, and it lowers fasting glucose over time. This effect builds gradually, and it depends on consistent activity. After meals, exercise changes where glucose goes. Instead of lingering in the bloodstream, more glucose is directed into the muscles. Less is actually converted to fat, and postprandial spikes are blunted. Even light activity matters here. Short walks after meals have been shown to significantly reduce post-meal glucose excursions. This is clinically important because post-meal spikes contribute disproportionately to A1C elevation, also oxidative stress and vascular damage. Regarding long-term adaptations, muscle becomes a glucose reservoir. With ongoing training, especially resistance training, muscle mass increases. More muscle means more storage space for glucose, also a higher baseline glucose disposal and improved metabolic flexibility. Muscle isn't just for movement. It's one of the body's primary tools for glucose regulation. Mitochondrial function also improves. Chronic exercise increases mitochondrial density and efficiency. This matters because impaired mitochondrial function contributes to insulin resistance. With improved mitochondrial health, it allows for enhanced fat oxidation, it reduces lipotoxicity that interferes with insulin signaling, and it improves overall glucose utilization. These changes help stabilize glucose control over time rather than just producing short-term drops. Now, the limitations and risks. Exercise is powerful, but it's not magic. There are important limitations to acknowledge. Insulin sensitivity gains fade within days if activity is stopped. Second, exercise alone may not normalize glucose in advanced diabetes. As beta cell function declines, exercise often needs to be combined with medication. Third, hypoglycemia risk exists, especially in people who are using insulin, those on sulfonylureas, or with prolonged or high-intensity activity without adjustment. This is why glucose monitoring, medication timing, and individualized planning matter. And fourth, acute intense exercise can raise glucose temporarily due to stress hormones. This isn't harmful, but it could be confusing without proper context. Finally, exercise is not weight dependent, but adherence dependent. The benefits depend on frequency, not perfection. What this means clinically is that exercise lowers blood glucose by directly moving glucose into the muscle. It improves insulin sensitivity. It reduces liver glucose output, blunting those post-meal spikes and increasing long-term metabolic capacity. It works through pathways that medications do not fully replicate, but it requires consistency, appropriate dosing, and integration with medical therapy. Exercise doesn't replace insulin. It doesn't replace medication, and it doesn't work overnight on lab values. What it does is change how the body handles glucose at the cellular level. That's why it remains one of the most evidence-supported tools in metabolic care. Powerful, but not standalone. When used thoughtfully, it becomes part of a system rather than a suggestion.